Hi there grade 9s and welcome back to WorksheetCloud Maths. Today we're going to carry on with our series of surface area and volume, and we are going to look again at the doubling effects on volume if we are doubling one of the measurements. But let's see what today holds. As it says there, we are into lesson 6, and the next time we come back together we are going to be starting a new section. Right, let's have a look at what today holds for us. Okay, so we're going to look at the effects on doubling on volume, as I said, and we're going to look at the cylinder first. Right, so there we have our cylinder. We've got our radius as being 5 centimeters and our height as being 15 centimeters, and we need to calculate this volume. Okay, so you know what the formula for volume is. Volume of a cylinder is pi r squared, because we're working out the surface area of the top circle, or the top circle, and the bottom, the circular base, in other words. So we've got two of those, and we are working out the height times by the height. So remember, if we're working out the surface area, we need to work out both bases, but we are only working out the one because we are working out the volume. So you work out the area of that times by the height. So it's pi r squared times height. Okay, so pi we know by now is 3,14. We've worked with that quite a lot in this series. And our radius is 5 centimeters. And we have to square that 5 centimeters to find out the surface area. And then we're going to times by our height of 15 centimeters. So let's square the radius first. And we're going to have 3,14 times 25 centimeters squared times by 15. Okay, and that is going to give us 1,177,5 centimeters cubed. This you can now do on your calculator. We don't need to go through it step by step, because I think by now you know exactly how to calculate it. Okay, remember, your calculator comes in very handy here, because you can't do these calculations just in your head. You could do them on a piece of paper. You know how to multiply, so all is good. Okay, right. Let's have a look. We now are going to double one of the measurements. Let's see what it asks us to double. So it says calculate the new volume of the cylinder if the height was doubled. So we know our height is 15. Double 15 is 30. So we're going to work with exactly the same formula as we did in the just working out the original volume, as you can see here. But instead of doing 15 here, we are going to do 30. So we've got pi r squared times height. We've got 3,14 times 5 centimeters squared times by 30. You can see that I've highlighted the 30 or made it bold. We then square our 5 centimeters as our radius. We get 25 centimeters squared, and then multiply the whole lot together using your calculator, and you're going to end up with 2,355 centimeters cubed. Remember, it's centimeters squared times centimeters is going to give me centimeters cubed. Okay, so now we've got our original volume of 1,177,5 centimeters cubed, and we've got our new volume of 2,355 centimeters cubed. Let's compare them by working out the ratio, and I'm sure you can predict what this is going to be, what this ratio is going to be. Okay, we did a lot of that comparing using a ratio when we looked at the effects of doubling on the volume of a rectangular prism, and we doubled the one side and saw what effect that had on the volume. Then we doubled two sides, and then we doubled all three. Okay, or measurements rather. Okay, so let's have a look here. So we've got our original volume, which is 1,177,5, and we've got our new volume being 2,355. And what we would do is we simplify them down until we've got our lowest number. And as you know, that a ratio is just the same as a fraction. So if we divide the one side by 1,177,5, we divide the other side by the same and see what we get to. And we end up with the fact that when we double one of the measurements, we double the volume. Can you see there? So 1177,5 doubled gives us 2355. So our ratio is 1:2, which means that our volume in our new with our new measurements has doubled. Okay, let's look at the next one. It says calculate the new volume of the cylinder if the radius was doubled. So now let's double the radius, and we're going to end up with 10 centimeters all squared. So it's 3,14 times 10 centimeters, and square that times by 15, because remember the 15 goes back to the original amount, which is your height. We've already doubled that, and that ended up doubling the volume. Let's see what this does. Okay, so 10 centimeters all squared gives us 100 centimeters. Remember, the reason I'm also saying 10 centimeters all squared is because you're not just putting the square on top of the centimeters or applying it to just the centimeters. You're applying it to the number of centimeters you have as well. So it's 3,14 times 100 centimeters squared times 15 centimeters, which gives us 4,710 centimeters cubed, which is different to the volume that we got when we just doubled the height. Okay, so let's see. There's our original volume again. Here is our new volume when we doubled the radius, and let's work that out as a ratio. So we're going to compare them. We've got our original volume as opposed to our new volume, 1177,5 and 4710, both centimeters cubed. Okay, again, remember, if one of them is centimeters squared and the other one is centimeters cubed, you cannot compare them, so you can't work out the ratio. But they are both centimeters cubed, so we can work out the ratio. And again, we're going to see how many times 1177,5 goes into 4,710 centimeters cubed. Can you guess? Sure you can. It is 1:4. So therefore, the volume in with the new measurement, with the radius being doubled, is 4 times as big as the original volume. Okay, so when we double the height, it doubles the volume. When we double the radius, it quadruples the volume. In other words, the volume becomes 4 times bigger. Okay, let's go on. Let's have a look now when we double the radius and the height. I'm sure you can predict this, but let's just go through the motions anyway. Okay, so we're going to now double the radius, which is 5 centimeters. It's going to become 10 centimeters, and we have to square that. And we're going to double the height, which is 15, and that's going to become 30. So let's do the working out. Pi, we know, is 3,14 times 10 centimeters squared. It's going to give us 100 centimeters squared times by 30 centimeters. Okay, there we go. It's times by 100 centimeters squared times by 30 centimeters. You can see both of those are bold, so that is what we have changed. And multiply that all out, we're going to end up with 9,420 centimeters cubed. Okay, so now we've got the original volume, the new volume, where both measurements were doubled, and we're going to find the ratio between the two. So we're going to compare by working out the ratio, original as to the new volume. There we have the two measurements, taken from there and taken from there. Again, we divide this one into this one, so we get 1 as to something. If it doesn't go exactly, maybe you can just halve them both and work like a fraction, like you're simplifying a fraction. Okay, this being the numerator and that being the denominator. Okay, everybody understand that? That's actually how you work with the ratio, but I'm sure you all knew that. Okay, so it gives us 1:8, and I'm sure you predicted that. Okay, so when we doubled the height only, it doubled the volume. When we doubled the radius only, it quadrupled the volume. It was 4 times bigger. When we double both of those measurements, it ends up being 8 times bigger. Okay, let's go on. So now you try. Here is your cylinder, there is your radius, and there is your height. And I want you to pause now. I want you to double either the height first, and then work out the volume, and then do your comparison in a ratio format. Then I want you to do it again, double your radius, work out the volume there, and work it out in a ratio, double both, and see what you find as opposed to the original volume. Okay, so pause the video now, start your working out, and then we'll come back and go over it together. Right, let's see how you did. Okay, we've put it over this side of the screen, and now we can do our working out. So the original volume, we've got pi r squared times height. We know that the r is the 2 centimeters, and there we have it, 2 centimeters all squared times the height of 25 centimeters. You can see it's a tall, narrow cylinder, this one. Okay, so the first thing we're going to do is take 2 centimeters all squared is going to give me 4 centimeters squared. There we have it in the next row. And then calculate that all together. It's going to give me 314 centimeters cubed. That's the original volume. Now we're going to double the height. Okay, so the new volume will be pi r squared again times height, and this time it's going to be times by 50. So there, I've bolded it for you so that you can see. I'm sure you've done it correctly. 3,14 times 2 centimeters squared times 50 centimeters. Again, the 2 centimeters squared becomes 4 centimeters squared. There we got it in the next line. Multiply it all together using your calculator, and you end up with 628 centimeters cubed. Okay, now we're going to double the radius, and the radius is 2 centimeters squared, so we now got 4 centimeters. Sorry, it's 2 centimeters. We're now going to square 4 centimeters. Okay, and we've got 3,14 times 4 centimeters all squared times 25. We end up with 3,14 times 16 centimeters squared times 25, and our answer of 1,256 centimeters cubed. Okay, so each of those amounts, each of those volumes are different. The one is 314, that was the original volume. Then we doubled the height and got 628, and then we doubled the radius only and got 1256 centimeters cubed. Now, can you see there is a relationship there that we worked out with our first cylinder with the yellow one? But let's see. Okay, so now we're going to double both of them and see what happens here. Okay, we're now going to make our radius 4 centimeters and our height 50 centimeters in the same calculation. Here we only did the height, there we only did the radius. Okay, so we've got 3,14 times by 4 centimeters all squared times 50 centimeters. It's going to give me 3,14 times 16 centimeters squared times 50 centimeters, and that gives me 2,512 centimeters cubed. Can you see this one is also different? Okay, so some people would have some people may have expected these two to be the same, even when we worked with the yellow cylinder, but we figured that they weren't the same. But let's compare all of them now with this cylinder. It's always good to work with a new shape to make sure that your theory is proved correct. Okay, don't always take what I tell you, always work out for yourself on a new shape, and then you can prove it to yourself. And as I've said in the previous lesson, if you can prove that to yourself, it means that that knowledge will stick. See, don't always say, okay, well, the teacher said so, it must be right. You prove it to yourself. Right. Anyway, let's go on. We are going to now compare working out the ratio. Okay, so we've got original volume as to the new volume, and the first one was where we doubled the height. So our original volume was 314 centimeters cubed, and our new volume when we doubled the height only was 628. You can all see that that is 1:2. So when we double the height in both cylinders that we've worked with, our volume doubled. Okay, so then the next one, we doubled the radius, and our original volume was 314, and our new volume there was 1,256. Okay, you can all, I'm sure, figure out that that is 1:4, which means that when you double the radius, we've worked it in 2 cylinders now. When we double the radius, then our volume is 4 times as big. Okay, everybody happy with that? Okay, then we doubled the radius and the height, and it's 314 as to 2512, and as you figured, it's 1 as to 8. So our volume is 8 times as big as the original, which is exactly what we worked out with our yellow cylinder. Okay, let's go on. What can we conclude? Okay, so we can conclude when we've worked with two cylinders, when we double the height of the cylinder, the original volume is doubled. When we double the radius of the cylinder, the original volume, is 4 times bigger. And when we double both the height and the radius of a cylinder, the original volume is 8 times bigger. Like I said, you make up your own cylinder, draw it yourself, make up the radius and the height, because remember it can be any measurements, and then you double first the height, then double the radius, and then double the height and the radius, and see if you get the same results. If you do, then that's pretty much the standard rule. If you don't, maybe go back and check or watch the video again to see where I may have gone wrong. And remember guys, if you want to comment on anything or you want to ask a question, don't forget to send an email to grade9@worksheetcloud.com. See, right, let's carry on and let's look at a triangular prism and see what happens here. So here we have our triangular prism, okay, and we are going to work out the volume for the triangular prism, right? And we know that the volume is the area of the triangular base, which is this one, okay, times by the height, which is that there. Okay, everybody happy with that? All right, so what is the area of the triangular base? It's half the base of the triangle times the perpendicular height. Okay, so there is our formula. And remember, we generally write the height of this prism as a capital H, not like that, because otherwise we might get confused. So it should actually be a capital H. Okay, we now plug in our measurements that we are given. It's going to be half times 4, which is the base of the triangle, times our perpendicular height, which is given to us here as being 6. Right. Then we're going to multiply that by 12, which is the height of the actual prism. Okay, so we're going to get 12 centimeters squared, because half times 4 is 2, times 6 is 12, and we're going to multiply that by the height of the prism, which is also 12 centimeters, and we're going to end up with 144 centimeters cubed. So that is our original volume for this triangular prism. Okay, and remember, you go and work it out on all this working on your own rectangle or triangular prism, and you can see if what works for this one can be applied to your one. Okay, right, so I've put the triangular prism here in the corner so we can keep on referring back to that, and there is our original volume. It's 144 centimeters cubed. So now we are going to double the height, and it's a capital H, so it's not the height, it's not our perpendicular height here, it's this height here. And if we double that, it's going to give us 24 centimeters. Okay, so again, the area of the triangular base, and that's half base times perpendicular height times the height which we are doubling. So we're going to go again half times 4 centimeters times 6 centimeters times by the 24 centimeters, which is double the prism's height. Okay, and again we're going to get 12 centimeters squared times by 24 centimeters, and that is going to give me 288 centimeters cubed. Right? Let's now double the perpendicular height. There's going to be quite a lot of working on this page. Okay, double the perpendicular height. We go back to our original height of the prism. We're going to go back to that measurement, but we're going to double this height here, which is our 6 centimeters. So we've got area of the triangular base times our height. It's going to be half base times perpendicular height times the height of the prism. We've got half times 4 times 12, because that is what we are doubling. Remember, we're doubling this, and then times 12. So half of 4 gives me 2, times 12 is 24, times 12. Okay, we end up with 288 centimeters cubed. Right, same as that. Okay, this is quite similar to our rectangular prism. Now we're going to double the base. There's the base there, it's 4 centimeters. So we get area of triangular base times height. We got half base times perpendicular height, and we are going to double this base. So it's going to be half of 8 times 6 times by 12. Everybody understand that? Okay, we've doubled that base. So half times 8 is 4, 4 times 6 is 24, 24 times 12 is going to give me again 288 centimeters cubed. Right, so there's our original volume. There's the volume when we just doubled the height. There's the volume when we doubled the perpendicular height. And there's the volume when we doubled the base. Can you see all of these are exactly the same? So basically when we double one of the measurements, we end up with the same volume. Okay, but we are now going to double the perpendicular height and the base. I'm sure you can already work out the ratio between these, but we will go over that later. Okay, so now we're doubling two of the measurements, the perpendicular height and the base. So that one is going to be 12 and that one's going to be 8. But this one stays 12. Okay, so there's our formula again. Half base times perpendicular height times the height of the prism. We're going to go half times 8 times 12 and then times that by 12. So half of 8 is 4. 4 times 12 is 48. Times by the 12 gives me 576 centimeters cubed. Okay, everybody happy? Right, now here's the original volume again. There we have double the height, double the perpendicular height, double the base, and now we've added on the new volume, which is the perpendicular perpendicular height and the base. Okay, and now we're going to double all the measurements and see what that ends up being. If you wanted to check, you could also double the base and the height of the whole prism, or you could double the perpendicular height and the height of the whole prism. We just did those two. Okay, let's work this out. We're doubling all the measurements. So we've got half the base times the perpendicular height times the height of the prism, and we're going to double all of them. So the base ends up being the base ends up being 8, the perpendicular height ends up being 12, and the height of the prism ends up being 24. There we have all the measurements that are doubled. We're going to now multiply it out. So half times 8 is 4, 4 times 12 is 48, and we're going to multiply that by 24, and we're going to get 1,152 centimeters cubed. Right, now there's all the measurements. Let's now compare these using the ratio. Okay, so these three we could probably just do it once because these are all the same measurements. So let's have a look. We've got our original volume as to our new volume, which is 144 centimeters cubed as to 288 centimeters cubed, and that was by doubling one measurement. Okay, and that is 1:2, which means when we double one measurement, our volume is doubled. Okay, it's 2 times as big or twice as big. When we double two measurements, we're going to end up with 1:4. Yes, you're absolutely right. I'm sure you predicted that. Okay, so when we double all three measurements, absolutely correct, we are 1:8, which means that our volume is 8 times bigger than our original volume because we have doubled all the measurements. Okay, so remember in a cylinder, we doubled the height, it doubled the volume. We doubled the radius, the volume was 4 times as big. We doubled both, it became 8 times as big. In a triangular prism, it's the same as a rectangular prism. You double one measurement and you double the volume. You double two measurements and you quadruple the volume, or it is 4 times as big. You double all the measurements and it becomes 8 times bigger. The volume becomes then 8 times bigger than the original volume. All right. Okay, now what can we conclude? As we've just said, when we double one of the measurements, the original volume is doubled. When we double two of the measurements, the original volume is 4 times bigger. And when we double all the measurements, the original volume is 8 times bigger. Okay, remember what I said to you? You go and you draw your own triangular prism with your own measurements in, and you work it in exactly the same way we've just done together, and then you can prove to yourself that this works. If it doesn't work out for you, either go back and check that where you've made a mistake. If you've made a mistake, come back to the video, check it again, and if you're still not convinced that I am correct, please send an email through to grade9@worksheetcloud.com. See? Right, guys, thank you so much for watching this lesson. I hope you have had fun with the surface area and volume series of lessons, and I hope you've learned a lot. And you can take this back to when you go back to school, and you will be ahead of the game. Well done, guys, and I'll see you next time.